We're going to use interval notation a lot in this course. Interval notation is used a lot in calculus courses also. So in this video we'll go over a handout on interval notation that's posted in Canvas. If you prefer, you can just read the handout. I'm just going to read through it myself here in this video. There are no exercises on it. We're going to apply interval notation in later sections of the course. We're going to use it all the way through, so it is important to be comfortable and familiar with this notation. So let's go ahead and work our way through this handout. The real number line gives us a way to visualize the set of all real numbers. Some examples of real numbers are 23, -8, 0, 2/3, 5.4193, pi, -2.8, square root of 2, cube root of 5/10. I mean, I could go on and on and on. It seems like almost anything. If you've ever heard of imaginary numbers, like square roots of negative numbers, they are not real numbers. So there are some kinds of numbers we work with in math that are not real numbers. They're called imaginary. Sometimes we talk about complex numbers. We'll discuss those later in this course. Each number that's a real number corresponds to a point on the real number line. We think of the real number line as being composed of infinitely many points in a row. Now, I know we're used to just kind of labeling a number line with integers. Here's another example that I just wrote out by hand. But if I wrote down a decimal like 2.4596308, I mean, that's a real number that sits somewhere, that has a point somewhere on the real number line, somewhere between 2 and 3, I don't know, right about there. Of course, its point is infinitely small, and there are infinitely many zillions and zillions and zillions of those points lined up on the number line. So try to see that number line not just as a line we draw, but as these billions upon zillions of trillions of little points all lined up, all crowded together. Sometimes we call that the continuum of the real numbers. And I like this thought that's here on this handout, this one statement: between any 2 points, no matter how close you make them, how close those two real numbers are, there are infinitely many more points in between. That's kind of a mind-blowing idea. Now, pieces of the real number line are called intervals. Intervals can be represented in several ways: by inequalities, by shading parts of a number line, and by interval notation. We need to learn interval notation for use in this course. First, a few inequality examples. The inequality 1 is less than x is less than 3 represents the interval that consists of all numbers between 1 and 3, not including the endpoints. And I just want to say one more thing about this. So when you see this kind of inequality, don't just think of an x sitting between a 1 and a 3. That this notation represents the infinity of all numbers between 1 and 3. And when you include fractions, decimals, all sorts of funny cube roots, square roots, eighth roots, tenth roots, there's, again, infinitely zillions and zillions of numbers between 1 and 3. So that it's a huge, it's not like just saying x equals 5 or 12 or 3. There's this infinity represented, this infinite continuum of numbers represented by an interval. Now, another inequality example is 2 less than or equal to x less than or equal to 5. That consists of all numbers between 2 and 5, including the endpoints. So sometimes we include the endpoints, sometimes we don't include the endpoints, sometimes we include one endpoint and not the other. So our preferred way of representing intervals is interval notation, and a square bracket is used to represent inclusion of an endpoint, and a parenthesis is used when an endpoint is not included. So on the handout there are several examples here that try to help you see how interval notation works. So we might have an inequality 20 is less than or equal to x is less than or equal to 50. That is an inequality that represents the number line pictured here, meaning all numbers from 20 to 50, including 20, including 50. In interval notation, we just write square bracket 20, comma, 50, square bracket. The inequality 11 is less than x is less than 13 on a number line represents all the numbers between 11 and 13 without the endpoints included. In interval notation, we write parentheses 11, comma, 13 parentheses. So it's a very succinct kind of shorthand, right? It doesn't tell the whole story. You have to know how to interpret the interval notation. Another example, 0 less than or equal to x less than square root of 2. It's this interval on the real number line. One endpoint is included, the other is not. In interval notation, we would put a square bracket on the 0, comma, square root of 2 would have parentheses. Sometimes we talk about an inequality or an interval that extends infinitely off to the right or to the left. For instance, x greater than or equal to 2. All numbers greater than or equal to 2. Well, all the numbers greater than or equal to 2 go off to the right on and on forever with 2 included. In interval notation, we write down square bracket 2, comma, we use the infinity symbol to represent this idea of extending on and on to the right with a parentheses on the end. If x is less than 4, if we want to represent all numbers less than 4, on a real number line, we would have an arrow going off to the left with an open circle at 4. In interval notation, we use the minus infinity symbol to represent a number line extending, an interval extending on and on and on to the left in the negative direction. Parentheses, negative infinity, comma, 4 parentheses. If we want to represent all real numbers, there's no inequality way to write that down. You could shade in the entire real number line. In interval notation, we write parentheses, minus infinity, comma, infinity, parentheses. The second page that I hand out now has some more important points to make here. Sometimes we want to denote a set of real numbers that consists of more than one interval. It's sort of like it's got pieces to this set, right? For example, all real numbers that are either between 0 and 5 or between 7 and 10, with 0 and 10 included but 5 and 7 not included. That's kind of a mouthful to say in English. Here are the three representations. Here's the inequality statement. Notice we use the word or, 0 less than or equal to x less than 5, or 7 less than x less than or equal to 10. On a real number line, we're shading in two separate pieces. It's like two separate intervals being considered at the same time. We're kind of saying x could be here or x could be here. In interval notation, the interval notation kind of mimics the fact that there are two separate pieces here, right? We have square bracket 0, comma 5 parentheses, and then we use the U union symbol in between, and then write parentheses 7, comma 10 square bracket. So the union symbol, or the U symbol here, takes the place of the word or and represents the fact that we have two separate pieces that we're considering at the same time. Another example is all real numbers that are between 1 and 10, except for the number 6, with 1 and 10 included. In other words, this sort of seems like one interval with just a hole in it, right? Well, in inequality notation, we have to write down two separate inequalities. Even though there's just a hole, we have to kind of think of this as two separate pieces stuck together. And the same thing holds for interval notation. It looks like two separate intervals, but really, when I write square bracket 0, comma 6 parentheses union parentheses 6, comma 10 square bracket, I just mean all the numbers from 0 to 10 with 6 left out, one number left out, endpoints included. Another example, one last example, is what if you want to represent all real numbers except negative 3. You're just leaving one number out of all the real numbers. Here's the inequality notation for that. The real number line picture is kind of nice, right? Because it looks like all the real numbers except one. There's one hole in it. In interval notation, again, because there's a hole, we have to represent the kind of like the left-hand side and the right-hand side as two separate pieces. Minus infinity, comma, negative 3, union, negative 3, comma, infinity. Now here are some examples of wrong things to do, and you want to make sure you avoid them. Number 1, it's incorrect to write a larger number before a smaller number in interval notation. The smaller number always goes first, and that applies to infinity and minus infinity. So infinity would always be on the right, minus infinity has to always be on the left. Number 2, this is wrong, to write square bracket 3 comma infinity square bracket. You can never put a square bracket around infinity or minus infinity. They can never be included. I mean, the infinity represents the idea that we go on and on and on and on to the right, but it's not actually a number you can include. That's why we never use a square bracket with infinity or minus infinity. And finally, one last note here. In math, unfortunately, sometimes we use the same notation to represent two totally different things. In such a case, we need to be aware of the context in order to decide the appropriate interpretation. This is the situation with something like parentheses 2 comma 5 parentheses, because that could represent coordinates of a point in the xy plane. But now with interval notation, that exact same writing could represent an interval on the real number line from 2 to 5 with the endpoints not included. Exact same notation, that means two totally different things. It's only context that can tell us which of the interpretations is correct. And I don't think it's going to be a problem, but you just need to be aware of it and to watch out for it. I think it'll always be clear when we're talking about a point and when we're talking about an interval in this course. And that's it.